Hey everyone, just getting started here. Just let me know if the audio levels are fine, stuff. If not, I will turn it up. Oh, sorry about the echo here. Um, we'll get started here in a second. Just let people come on in. But until then, feel free to chat, ask any questions that you have, and yeah, just okay. Alrighty, let's get everything set up here. Where is that camera? Okay, cool. Well, just a little bit of kind of maintenance stuff. Last time I integrated this chat window, or I moved it over here, I wonder if that was better than what I had before. I know it does cover up some part of the screen. Most of the time it's like, it's like here, so it's not really interfering. As long as I keep this outline up here, it should be okay, I think. But just let me know if you have any other suggestions. Using an IDE on a stream is kind of difficult for this reason, right? You want to have the chat, but you also want to use all the screen space. Cool. Well, how's everyone doing out there? It's a really nice morning, quite warm out here, actually here in Japan land. Just trying to stay cool. Don't have my air conditioner on. It does make quite a bit of noise, and just electric bill out here right now is kind of crazy. So I'm trying to avoid it as long as possible. I got my water and I got my coffee. So okay, got some people in the stream. It looks like. Let's see. Oh, Explosion Force. Hey, welcome back. Really appreciate you dropping on in. Yeah, it's been a while. I didn't stream for like a month at one point because of work and other things. You can see here, but there's a big gap between committing in April 26th and May 16th. So, yeah, things are going good now. Back in my morning routine. Now the weather is nice and warm. It's much easier to get going. Yeah. Harder to get motivated in cold mornings, so. Well, while everybody's following in, I'm just going to review a little bit about what we've done. As you can see, we started setting up our character data, which is going to be used to customize behavior per character on implement unique moves and things like that. Specify hitboxes, hit properties, such etc. 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 Yeah, so we had done that a while ago, and then what we've done recently is we're able to serialize that data into JSON, right? We wrote a few tests for that, and last time, what I actually integrating a reading that JSON asset into character data files. Actually, we kind of had generic support for loading JSON as long as they kind of followed our rules, such as using array lists for arrays instead of just plain arrays. Wrote a few, not real tests, but just a kind of like print out debug information that time when I streamed. But actually, since then, I didn't really want to do this on the stream. I did some proper validation on the code and wrote true tests that actually test for things such as like just validating array list work, validating. Well, I can just look at here. It's much easier, I think. Yeah. Let's see. Yeah. At some point, I want to move these tests to a separate file, but I think this is fine for now. Obviously, if it gets a little unwieldy and too large, we'll have to start moving things around. Yeah, so testing deserializing a single struct with a single field. Here you have a message. Well, this one is with a single character string field. I should have wrote deserializing a struct with a single, not character string field, not a single character, but a I don't know why I said single character. Single variable, well, single string field. But yeah, yeah, actually, that's another thing. I did add support for loading strings, and this just validates that. And this is for testing struct with a single integer field and then an empty struct, as you can see. Well, that's pretty much what I did last time. And I think we're probably good to go now on the new stuff. Let me just test this. Oh, I didn't mean to open Unreal. Give me a second here. Yeah, that's the wrong one. I don't want that. There we go. Okay, we had quite a few people here. And I appreciate y'all for coming by. Didn't mean to open that. Okay, cool. Let's look at the agenda. And I actually want to talk about a few things coming up. But so before we get, so basically the idea is now that we have serialization working, we need to actually create a character asset and load it when we start the game. In the future, it's gonna be based on which characters you select and such, but we won't get there right away. And of course, we're going to use the loaded character data when executing actions in the state machine, which basically means that we're reading things like hitboxes, hit properties, timings, etc., etc., etc. One thing I want to get to is also supporting in-game reloading of character data to support rapid iteration, which means we can press like F5 and reload instantly when we make a change to character data, so we don't have to relaunch the game and go through the whole thing. That's going to also be really important once we actually have game state. We're going from like a main menu or whatever, or character select. Though I don't know if the project will get to that point, to be honest. But anyway, yeah, rapid iteration, because startup time is quite annoying. Yeah, so and we're also going to have to pipeline the hitboxes into the character collision system. So we had a very the way we're doing the collision system is kind of like we prepare a bunch of hitboxes and then we quickly run through them just for performance reasons, and also to isolate what the collision system from the rest of the game. Yeah, and then I want to have two characters on screen, each with at least one hitbox. We're going to fire off debug messages to collide just for testing, and only when they initially overlap. So that's gonna contribute to a lot of functionality. Like only when they initially overlap, it's like when you hit some character in a game, you don't want the hitbox to continually hit them, right? You only want it to trigger an event the first time. So that's important for the fighting game stuff. Okay, that's kind of what I want to do for this month. We only have about a little over a week left. Maybe we'll get into more stuff than that, but that's for the rest of the month. And then I want to talk a little bit about the future here. My kind of plans, if you've seen in the chat, is to get this done mostly by the end of the year. And I think we can do it if I can get enough streams in. But cool. Yeah, so what's coming up in July is we're going to start doing attacks. Maybe we even get to that this month. We'll see. We're going to have the ability to save and load attack data from individual files. So the thing there is basically we're going to want to have attacks in their own files, so it's better for source control, things like that. So we won't have one giant file that everybody... Even though I'm the only person working on this, it is a little bit better to isolate that stuff, I think. Just comes from experience, instead of having one giant massive file per character for all the moves. Yeah, I want to have like in-game hitbox editing. We're going to integrate the proper versions of all these attacks and actions. We're going to have a reaction system next month. Implement all the hit stun, block stun, hit stop, hit shake, all that nice stuff you want from fighting games. Trades, knockback launch physics, knockdown state, transitions, and clashing. So this is pretty much all the collision interaction stuff, right? And including the basic movement. Hopefully we can get that all done in July. I think if I can do like 7 or 8 streams, it might be possible. We'll see. Yeah, so that's coming up. Unfortunately, it's been a little boring the last few months. We've had like the low level stuff we need to integrate first, but once we get that data pipeline in, things are going to be much quicker. And after that, it's kind of this core fighting game stuff's in. So I want to have we'll do like a basic training mode and debug tools for let us like rapidly iterate on the actual character system and stuff like that. We're going to start finally integrating the input history buffer. So this is going to be used for things like registering special moves, right? That's coming up. I may move it up here. We'll see how things go. And we'll do some special moves and then camera tracking. The reason I put this as not as long as this one is I might actually move stuff from July to August. Same with September. What else are we coming up? I want to start integrating a match state. So basically, we're going to have round start during match, round end. Because you have a bunch of things that the game needs to do during specific phases of a match, and you have like between rounds and things like that. I'm gonna get also around to combo damage, hit stun scaling. This is like deterioration of hit stun over long. I haven't decided if this game is going to use hit stun scaling, hit stun deterioration yet, but this is kind of the general ideas. We're going to have to do something about preventing infinites and such. I want to get to the throws and the locking mechanism. So it's basically how you lock a character into a throw, all that kind of nice stuff. That's very important as well. I think it's more of the core fighting game stuff. I might move it to another phase. These are not things that are set in stone, but these are things we have to do. And yeah, after that point, I'm going to get into the network code. Generally, I would start the network stuff as soon as possible, and I might actually end up doing that. The way we've kind of designed this gameplay architecture, it's intended for rollbacks, right? Where we have state that can be copied over to the next frame, or copied and then restored if we need to. So actually, I might do that a little earlier. We'll see. Yeah, rollbacks, and after that, probably some things like optimization, debugging, desynchronizations, et cetera, et cetera. Yeah. Okay. Well, with that bookkeeping kind of stuff taken care of, let's get started for the day. So I kind of wanted to do this from a let's start from what we think is going to be the actual code executing in the game during gameplay and work backwards, right? Because we're going to have to pipeline that data all the way from loading to the collision system first of all, okay? And I'm going to just write some stuff here real quick just so we can think through this before we actually put down any code. It's just kind of an exercise I want to go through. So, yeah, so creating character asset, yeah, that's kind of obvious. But let's just think it from the start. Have a little bit of scratch here. So how do we do it? So let's just write in plain English language, right? When a collision, so before a collision occurs, so when a collision occurs, show a debug message. So this is just going to be what we're doing for now. Eventually we're going to do all the hit property and stuff like that. Now working from that, to get to the point where we actually can do a collision, or do this, we actually have to detect collisions. So, detect, overlapping, I don't know how to spell actually, hitboxes, which we've done already. We kind of have that code working. I believe it's working. We have to double check on that. And working backwards again, we need to get the hitboxes into the collision system. So get hitboxes into collision system. Still working backwards. At some point between this and we have make money. What is it? The underwear gnomes or something. It's like get underwear, make profit. That's pretty much what we're getting to, right? So load character data. So this is kind of the gap we need to fill in here, right? And before we get into anything concrete, we need to think. There's two ways to do this, right? You can start thinking about the data first, or you can start thinking about the algorithms first. Often, if you just think about the data, the algorithms kind of fall out, right? If you're using a hash map to store your data, well, you need a key, and you need to pull that key from somewhere or store it somewhere. So that's the kind of thing. So read a key, or get a key, read the data from the hash map, and then get your data. Now, just talking through this, once we load the character data, we're going to store it in. We have our persistent store, right? I think we've looked at before. Is it in the game simulation? Yeah, we have our game data, and this has this variable game data. Well, the struct game data just has characters, and it's just an array list of characters. So we'll be reading from that. Sorry. So we're going to need, I got some ice in my mouth. So when we're actually reading the character data, what do we need to actually access that? Again, if we're thinking things like a hash map, we need a key. Well, in a fighting game, let's say you have two characters, you need the character index, right? Or some reference to the character. And you need the action, so you can pull down the right hitboxes for the action, and the frame of that action, or some way to know what hitboxes are active currently. So let's just write down what we need here, right? Need character index, action, current action, and so this way we can just look at the action, pull down the hitbox that we need for a particular frame, and go. And I believe we did integrate some of that functionality here. Where is our outline? So we go down to action properties. So we've hitbox groups here. Oh yeah, so his active on frame. So we have a function that's like, sees if hitbox group is active. And have we used that yet? We haven't used that actually, but we're going to use it. Yay. So I think we're going to use that. Well, let's just look a little bit at our collision system really quick. So what we're doing in internals of that, right? So yeah, we haven't got our game state or using our game state yet. So yeah, we'll have like a get active hitbox sort of thing. Where are we at? Now we actually have this function. So yeah, this get active hitboxes. So we're passing in the game state and the entity. So the entity ID is what I was talking about as far as like a character index goes. So yeah, we haven't done anything with this function yet. Let's see. So we also have do hitbox overlap. So we have the functionality for checking to see if the overlap. Let's just work backwards here through the code now, just to review a little bit. So what are we doing? We're looping over all the defender hitboxes, the attacker hitboxes. Sorry. Yeah, and we're going to do something like, for now, we're going to do like what debug, print, like that. We're going to do something like that, right? Just as a debug test. And are we using the scratch memory yet or doing anything with that? No, we're not. So yeah, we actually need to pull in the hitboxes here. The way we're planning to do it was a loop over every entity. So it's something like this. So we implemented this translate hitbox, didn't we? So yeah, we translate the hitbox. So basically we're going to go through all the entities, get their physics component, the position, translate, and then we need to translate the hitbox per hitbox. So we need to do this get active hitboxes thing, right? For a particular entity. Now this doesn't have a reference to the game state. So we also need, did we store, where's the game state? Yeah, so we have it in the game state. Okay. Now, I might change this in the future for optimization's sakes, but actually what I've been thinking lately is I'm going to do things the most straightforward way first, and then if we want to make improvements to it, I'll do it after that. I just want to do things in this much more like straightforward manner. Like if you need this data, pull it for now, and then we'll work on improving the pipeline later. I just want to get into the meat of the fighting game stuff and not focus so much on the optimal pipelining of data right now. Yeah, okay, because it's easy to get bogged down in that stuff. Okay, alrighty, so getting back into this. So we are getting the active hitboxes with this function, but we need to pass in the game state too, so that we can actually pull down the correct entity. I thought I made a function like this. I did not make. Okay, I did not make a get active hitboxes function. So we need a function that's like get active hitboxes. So basically, oops. So think about it more. We need to get. Let's write things down real quick. So just going down here. So we need to loop through all hitbox groups for the active action, then loop through each hitbox group and choose the ones that are active for the current frame. Okay, so basically I'm going to write everything in line here because we don't have this function yet, right? So what we have to do, and then we're, yeah. So, okay, yeah, we got to get the active action, right? So in order to get the active action, we need a reference to the state machine component. Going back to the state machine component, where is that at? Oops. Is that on the state machine? A component does it. So, did we put in here? No, we have the fixes component. We don't have the state machine component here. Hold on, give me a second here. We said we did have our state machine. Yeah, there we go. Okay. Something like this, and then going to the collision system. So for each entity, we need to get their state machine component. Which should give us their active action, right? So in that component, we got something like in context we have this. Oh, we don't. Oh, we did some weird stuff with the context, right? Oops. I forgot all that weird stuff we had done. That was a while ago. It sounds like a dog's barking outside. I don't know if you all can hear that, but yeah. Okay. Let's just look at the context real quick. This should store the current state. So we got next state. Oh. Hold on quick. Yeah, so we do have a current state. Oh, we're storing that in the state machine itself. Did I really store that in the state machine? This might be a mistake on my part. So we have this combat state machine processor thing. I might want to have to redesign this. Now, I hate when I run into a problem I didn't realize before. Just give me a second here. Okay, each component has a state machine. Okay, it's fine. We have a state machine in context. It seems weird to me that I separated those, now that I think about it. But we'll just live with it for now. Okay, we'll have to live with it. So instead of the state, so we need the component, and then we need the component dot state machine, right? Yeah, there we go. And then we need current. Oh, because really, I hate when the autocomplete can't find the stuff. Well, that's not ideal. It's probably because I'm not including it, importing it in this particular file. Anyway, where's our state machine? Yeah, it's called current state, right? Okay. Okay. So we have our current state. And just for now, let's just put current state. We can change these things around real quick. So we have the current state. We need the current frame. So for now, we don't have a current frame, right? Let's go back to our state machine real quick. Because we're looking here, so we have active action or state, and then we need to pick the hitbox groups that are active, right? We never got to the point of actually having a frame for that action yet, or a timeline that updates that frame. Do I want to do that today? Not sure, but let's look here real quick. So let's state registry, combat state callbacks. I'm looking for that. Current state is just the enum, an ID, context. Yeah, where's the context at? So I'm not quite sure where I install the current frame yet. Insert the current frame. So for now, we're going to skip doing the frame check. We're just going to assume all hitboxes are active on the action at all times. We're going to come in and then add that additional filter for getting what. Later, we're going to add that, where we check the current frame and see which hitboxes are active. So to avoid that complication for now, we won't get the current frame. So we just need to loop through all of the active hitbox groups and then get all the hitboxes, translate them, store them off in our scratch data, and go, right? So that's where we're going from here. Cool, so we get the current state. So this is the tricky part. We actually have to get the action for the current state, okay? So we need something like, let's just thinking abstract level, like find state, and we have to pass in like, what we need to pass in? Well, we have the game state dot game data dot, see, it's not even, I hate that. Yeah, no, I really wish we had autocomplete here. So let me open this. It's in the game simulation. We have the game data, game state. That's our game data. There we go. So it's characters. Okay. Well, yeah. So characters, and it'll be like, I think items is what I'm looking for here, and we need the entity. And that should give us a reference to the game data for that character. And then we need to pass in current state. That's the idea. We could make this a function on the character data itself. So let's just say find action, right? Find action, because we're referring to these as actions. So let's go down to action properties, character properties. Okay, we don't have a find action function or anything like that, so we need a pub function find action. We need to pass in the enum for the character state. That is called a, what is that called? Combat state ID. Okay, we could just pass an int and then convert it later. I'm probably gonna move this to another file, but yeah, let's go to character data. So we need a combat state ID to be type safe, right? If it's just an integer, it might be, it's not type safe. So state ID. And then let's do, we need to find in, oops, no, we need a self, right? We need a self, and that needs to be type character properties. Yeah. And we need to return an optional, because we may not be able to find it. We need to return a action, or a const. Can we do const here? Action property. That really naming app action properties? Yeah, that's fine. Can we not have const here? Okay. I'll get back on that. I don't want to actually be able to modify this stuff. It needs to be all const properties. Actually, how do we have const return? Can we do like a const pointer or something? I'll look at that later. Okay, so yeah. So basically, we just need to loop. Well, we don't even have to loop, right? We'll just do this. So if state ID is greater than the actions dot items dot length, then we know we don't have the items, so we need to return. So this is not, okay, let me put it this way. This is not actually what I want to do, because we're going to be writing. So basically we have two kinds of actions, right? We have shared actions, like all the movement stuff, and then we'll have IDs for attacks, which those are unique to each character. So I don't know if I want to use enum to actually find these things. So just double back and think actually how we want to handle this. We could just have strings that look up the name of the action, and based on this in something that we store in this state. That is kind of a straightforward way to do it. It's not entirely performant, but that way we can actually have a hash map that we can look up that gets initialized when we load in the character data, and we just look up the index based on that string. We could even do like compile time hashing if we wanted to, so it's really just you don't have to do the hash every time. This is something to think about. But yeah, we'll start, because that seems like a decent approach, I think, for now. Let's give unique names to these actions. So what we'll have to do, doubling back on the character, on the action stuff, we could either store the name of the action properties. So let's just for now do that. Let's give it a name and make that I think U8 slice. I think that's the way I want to go about it. I think that's the right type I want to do for it. Or did it be const U8? Anyway, I'll start with the U8 slice for the string. And let me look at, hold on real quick. This is actually kind of cool reason why you want to write tests, right? So you can validate the code you wrote before and how it actually works. So just as a struct message, and how do we do this? So yeah, so our message is U8. Okay, that's what I wanted. Coolio. So we have the name of the action, and then within our character properties, this is going to be kind of tricky, because I don't want to serialize a hash map to JSON and then load it. But I do want it to be part of the character. in the namespace actually. Well, not the namespace, but unique. So let's just say like name map, action name map, right? So we'll pass in like the we don't actually need this, right? Actually, so we need to, instead of passing the state ID, we need to pass in a, what is it, would be a const u8? What is a u8? Const u8? Well, action name would be const u8 maybe? I'm still very much in C programming mode, right? We can't do that? What did I do wrong here? It can't be a u8 either. Oh, it can be u8? Okay. Oh, everything's const by default. Hey, what's up, Christoph? I always have to forget that, like, passing in things are const by default, so I don't need to write const. That's a little tricky. Oh, it goes between brackets and u8. Good. Okay, thank you. I'm very much in C mindset. So, there you go. But yeah, I want to do const wherever possible. So, yeah, we want to do const here as well. That doesn't work. Oh, it's const by default, right? I'm insane. So we'll have a hash map. We'll return that. But the action map, obviously this is kind of a C syntax for a map. I haven't used the hash maps in Zig yet, so let's look up the hash map. Okay. This is one. Whoa! Well, I just spilled coffee over my lap. That is fun. I'll be right back. All right, a little bit of accent there, but I think we're good now. Okay. You're right. The pointer itself would be mutable. Gotcha. Okay. Yeah, let's look at the hash maps real quick. Oops. Is there like a learn Zig hash map thing? I was looking at this documentation for. I thought there's a learn Zig book. I've seen it many times before. Yeah. Is this it? Yeah. I don't. Oh, hash maps. Here we go. Cool. Actually, I probably did document in our Zig notes. Okay, yeah, here we go. So we have hash maps with string keys and value of type V. A hash map with key type K and value type K. This is I forgot the auto. Yeah, auto hash map, just any key type. So we could just use the string hash map, I think. Hash maps that doesn't store its own allocator. Do we want one with allocator or not? Well, we'd have to initialize it. I think it's fine. Let's just initialize it with the allocator. All the current docs are broken. Okay. Oh, you're actually working on that. That's really cool. Well, generally, I'll just look at the repository, right? Oops. It's only worth using an unmanaged hash map if you plan to have a ton of those. In this case, we're not going to do a lot of lookups, I guess. We did need yeah, so that's what I was thinking. What is it called? Should probably get, that's the documentation. I want the documentation. I want the code. Okay. Standard hash map, string hash map, unmanaged. So, where's the test at? Is there tests for the hash map anywhere? Wait, hold on. It'll be under hash map. Where's hash map at? Hold on. Don't want to go there, sorry. Is there a hash map? Okay. String. Oh, so you're passing comp time type for the value. And it just creates a hash map that is a const u8. Okay, makes sense. I don't know what the string context is. Okay. So there's no specific test for the string hash map. Right? It's just for hash maps in general. Yo, what's up, comic man? How's it going? So hash map basic usage. This is with the hot auto hash map. So yeah, I don't necessarily know. I'm gonna have a lot of hash maps for looking up actions for a character in their like data store. If it does, I'll switch to unmanaged. It doesn't really matter. I have the allocator how do I want to do this? I just don't know if I want to pass an allocator through a chain of function calls. Right? This is something I have to think about. I want to avoid passing allocator to everything in my code base, right? Like, oh, just so I can read data from this asset, I need to pass in an allocator. Well, do I actually need to pass in an allocator to? Well, I guess I would, right? Because that's where the memory would be stored. Huh. Oh, I'm doing good, comic man. Also, the hash map is storing, right? Okay. I'm thinking, my mind is like thinking in terms of like contexts and passing in context to code that evaluates it. Okay, great. Yeah, this hash map is in runtime. It's not something we'll be for the gameplay anyway. It's not something we'll be writing to. Oh, great. Okay, so I can use the unmanaged one. That sounds awesome. Unmanaged. Whoops. Well, one thing I do love about Zig is just the source code is so easy to understand. So you can read through the standard library stuff, and it just makes sense. Even, you know, it's pretty awesome. Okay. So yeah, it just doesn't take a key. I want to see the usage here real quick. Oh, is this auto hash map? Is this unmanaged? Okay. Just want to see usage of it real quick. Oh wait, is unmanaged itself another kind of type? Where is hash map unmanaged? What's this stuff? We're going down a rabbit hole here. Yeah, Squeak, thanks you. I do understand that I need to pass an allocator only on init for a managed hash map, but I think Christoph was suggesting that I use unmanaged, because honestly, I won't be inserting outside of loading time. I will not be inserting anything into the hash map. Oh yeah, pub. You're right. Pub function gives us everything that's available. Oh, that's a lot. Okay. Let's just get started on something here, so I'm not dilly-daddling around. Let's see, unmanaged. Is it unmanaged string hash map unmanaged, right? Okay. I'm just gonna go from here, right? So let's get started on that. So let's store that inside of our character. One thing we'll have to do is ignore this type for loading JSON, but we'll get to that at some point. Okay. So we called it action name map. It's going to be this. It's going to be a string, and it's going to be of types. It's going to be a map of to action pointers, right? So action properties. Is that right? Or my brain is just not working here. Oh, it needs to be a comma. Hold on. Yeah. Hold on. Yeah, I forgot we have this control tab thing. Going back to character data. So yeah, I only have a few hash maps for this character. For now, it's only gonna be a few. Okay, well, let's just do. So it needs to be a standard. What is it? Hash? It's gonna be here string hash map. Okay, let's just do string hash map. And when we need to init this, right? So action name map will need to be would it be standard string hash map init? What? Oh, maybe you can't find it. Maybe you can't just find an init function. So we just need to pass an allocator, that's all. I still need to initiate a concrete type first. You're right, you're correct on that. So it needs to be action properties, pointer to action properties. Okay. Because this is gonna, well, we could do a pointer to, you know what, do we do index, do we do a pointer? Let's do an index for now. Let's just do index. So we don't have to deal with pointers, right? Let's just do, what is it? usize is usually what you use for indexes, is usize, right? Yeah, cool. We got that. So this will be just an index into the array list that we load. We might change the way we handle this later, but I'm gonna stick with that for now. Okay, so assuming that works, we can find an action, and we'll return the optional pointer to the action properties. That's the best way to go about it. This is the way you handle it. It's like that. Well, we're not doing it like that, obviously. We need to get the index of it. So it'd be something like const index would be the action name. Oops. Action name map. Actually, how do we use? Is it? Oh, it needs to be self.action name map dot. Is it find? Yeah, how do we use this? Is there a pub function? Get, is it get? So we need to pass in self and a key. Is there a test here so I can validate how it works? Let's do get. Hash map basic usage. Try expect equals I map get I. Why I is count. So do we need to do a try? Well, let's for now, let's just do like get action name. Can we do something like this and pass in? Does this kind of work? I don't know. Oh, that's cool. That's really nice. Okay, awesome. I'm glad I'm going to use the idiomatic usage of Zig here. Okay, and then also I'm going to return null here, and then if index is, well, since our code isn't responsible for loading all this stuff, let's assume it's correct, right? We shouldn't have to. We can assert, right? We can assert, hold on. What does it assert in Zig? Expect? That's what it's called? Expect? No, it's not. Is it? What is an assert in Zig? I want to use an assert. Oh, it's const standard assert. Okay. Great. I'm going to throw. Okay, expect is for test. Great. Okay, great. Okay, I'm just going to do this little convenient little thing here. It does. And then I'm going to assert. So I'm going to assert that the index is less than the our actions dot items dot length, right? And then we're just going to return the action properties, index and action, and return the, this is not like C. Also, that's spelled wrong. I need to actually return the address pointer. Okay, that is okay, so we actually, I want to write a test for this because what time is it now? Okay, we got time. So I need to write a test to actually validate this works. When I actually need to load, we'll initialize the hash map as well after our deserialization process. Oh, sorry, it's redundant. Okay, cool, awesome. Just cool. I'm used to C. You know, raw array access, which is like nothing is checked there. Writing C code for games, he's like, oh, let's start all the things. Cool. What should I do? Oh yeah, let's write a test here, and it's also like, okay, let's write a test. So So we don't want to test deserialization part. We just want to test that stuff's in the hash map, right? So first of all, we need the right function to actually set up the hash map. I don't know what to call it. Let's just call it something like that. Oh, actually, this needs to be a pointer, right? Or am I crazy? And I don't know anything. Nothing there. Oops. Oh, when you. Maybe it has to be. Okay. And we'll need to like loop through everything in this list. So. Gotcha. So for self dot actions, we'll have I think action. Let's do action here. Okay. Action dot name. That's what we did. So with the action dot name, we need to, isn't it try self dot action name map dot insert? Not insert. Put is a name. Okay, put, and that just takes. How do we do that? Put takes. I guess key and value. Hopefully, key and then value. Oh, we need index here too, right? Index. Okay. Now this assumes we don't have duplicates of the key. But yeah. So we need a test that validates this function, right? So yeah, this is all the serialization stuff. I want to put it above here. So I don't even need this thing anymore. Test resizable array. I'll probably get rid of that. Just lack of. I just like putting things at the very end when I'm working on it, and then I can move it. Okay. Put no clobber. Thank you about that. Put no clobber. Self key value. Okay. Well, that's exactly what I would love to use. Is that? Thank you very much, Christoph, for the suggestion. Okay. And what do I do? Trying to keep my thoughts straight. Okay, so we need to set up a character. Did we write a test for that? Because I want to copy that code. I don't think we did. Which I'm kind of upset about. Oh, we have something like this. I'll just use this. Okay. So just getting a read an allocator here. Setting up the characters with allocator. Make an action. We're just gonna append that action. So, oops. And actually, the action needs a name, right? Ooh, I just realized that action does not have a name. we do need to go to it, and I mean, the name is not initialized to anything. So is it possible it's initialized to a slice to nothing at the beginning? I'm still learning Zig stuff. Okay. I know we have allocator dot alloc. So I know I can like make a string like this. But it has to be const u8. That means the pointer can't be modified, right? Or is it pointing to a const, an unmodifiable string? That's what it means, right? It's pointing to a non-modifiable string. It's like C. It's like a const pointer, I imagine. Or reference to also hello. Oh, I'm trying to parse what you just wrote there, Christoph. Yeah, I don't plan to modify the string through the point. Well, okay. Let's think about this real quick. On one hand, yeah, I don't tend to modify the string itself, but so on loading, what happens is going to need to allocate the memory for that string, right? Because it's coming from the JSON asset. Because it's not a string literal that's written to the code, right? It's loaded from a JSON asset, so I need to actually copy that string into some allocated memory. Oh, thank you, Christoph. So I was thinking of just allocating the memory on load, like just something like this. Hold on. So action.name equals, we don't have a string length, so I'm just trying to think of the best way to handle it. So like const my foo, equals jump, name of action. Then you can do foo.length and then action.name equals foo. I might want to do this more elegantly. But it makes it var if action name is u8. Yeah, so const u8. So it's an array, a slice that's pointing to the start of an unmodifiable string of u8s, right? That's the way we want to think about this. Just try to get it all straight in my head. Cool. I need this coming from C. It has weird ways of putting const on stuff, and it's confusing as heck. But this is much more straightforward, so you can actually parse it. No like left, what is it called, west east rules with some, I don't know, that's kind of crap. now you can also do action name banana your test. You can just want to copy. You just want to copy food to the heap. Try allocator dupe. That returns a pointer. Not heap. Well, yeah. Well, for now, let's not allocate the memory. Let's just do what Christoph suggested, which is just point to a string literal for now. And we'll deal with that, testing that stuff later on initializing our actions. And so we'll start pointing. The problem is I don't like to put anything ever in an invalid state, but as long as things being temporarily in what I would consider an invalid state bothers me. That's why I don't like, hold on. Whoops. Like this equals, oops. No. Technically this is not a valid string ever, but yeah, each language does things differently. But for now, I won't worry too much about invalid state having an action without a name. We'll just append this action with this name. So let's append two actions. This makes copies, right? Should make a copy. Yeah, it should be copies. And then we could do character dot initialize action name map, and then we should be able to find character dot find action. So we should be able to do character if find action jump, right? Actually, that's not how you want to do it, right? We want to do try center.testing.expect. Is there a quick way to check for, okay, can we do something like this? See if it found it or not. Cool. Does this I'm gonna convert to bool, or do you have to do something like doesn't equal null? Is that better? I'm just trying to test to see if we found the action or not. So like zig test source, probably some errors in here. No memory name length instruct. Where is that at? 101. Oh, it needs to be items, right? No items. Oh, right. I'm stupid. Hold on. Okay. So find action, we get, I'm an idiot. Okay, sorry, I'm gonna call myself an idiot a lot here. I didn't want to do that. I need to return. Okay, 103. Someone is watering the plants outside my door. Do I need this? Error. Oh, right. Need to try all the things. One of these days, I'm gonna get a hold of error checking in Zig. Okay, so all the tests passed here. Let's try this. Let's try jump, run, exist, and then let's try should equals noon. Okay. So all these pass, and if I wrote like this should fail, right? Okay. That fails. And these should also fail, right? If I do equals null. Okay, great. So that puts us in a place to actually pull in data for the character. We still need to initialize in our, through our pipeline. We still need to like load that data in, do this whole initialize action name map. We need to, when we actually deserialize, we need to store. Well, luckily our code, you know what? Yeah, luckily our Json parser does the whole allocation of strings for us, so we don't have to worry about that. I have a test for that already up here. Where was that? Yeah, here's message hello Zig, and yeah, and expects this to work. So just going back to what we're doing. So to get to that point, it's always more than you expect, right? When you're doing this stuff, there's more work than you planned for. We got very deep into Zig land, but I think we're going back into game land now. We need to get focused here and get back to, well, the collision system, because I'm trying to like work backwards again. Did not make my own Json parser. I used the built-in parser and then some compile time code to iterate through all the fields in the structs and subfields and handle them in a unique way, right? I basically load things into the Json parse tree and pull values based on the actual compile time information, type information for the struct, instead of like the automatic, what do you call it? The automatic deserialization. No, I'm not doing the Json parsing myself. I'm overlapping meanings there, parsing, deserialization. Basically made our own deserializer. Using some of the built-in functionality. Okay, blah. So what's next steps here? Try to get focused. So going back to collision system. Hold on. Okay. So we need to find action. So this is going to be replaced, right, with GameState.GameData.Characters.Items entity. It's going to be like find action. Is that what we called it? And that will pass in action name. And we'll have to get the name somewhere. Where do we get the name from? We'll get well, this is not the name, right? But we're going to have to store the name somewhere. We can't use the enum name because we'll have actions that are not named enums. They'll just be an index. So we'll have to store, for now at least, the name in the state itself, I guess. So we'll have to get the state get it from the state properties. What do we store in the state right now, actually? Let me look at that real quick. State machine. What do we have here? Let's look at outline. We have a combat state context, which is we don't want to store in the context because it needs to be const value basically throughout the lifetime of the game, lifetime of the match. So our registry stores a list of callbacks, and the list of callbacks, that's what we called it before. We're just, where is that? Yeah. So for a state, we store these callbacks, which just give us this. I'm going to rename this actually because now we need to give a name to our state, right? So it's not a terrible name, a good name for things that store properties about a state in a state machine, because now we're going to have not just callbacks but a name. So right, name's also going to be a slice pointing to a constant string, and we're going to store that obviously. Again, a thing I'm not super happy about, but it starts in an invalid state. And we had some code for setting this up, right? Common states, right? So we have to go through the common states. So far, we just had standing, walking forward, right? Actually, how did we do this? So we made an anonymous struct for these states. Not anonymous, it's the name of the state. These are just the definitions of the callback. So how do we handle this? Let's go back to our game simulation. We signed it all here. So basically, I'm going to make these way more convenient because we have the standing callbacks. Now we're going to have to add a name, right? Equals standing. And we need name equals walking forward. So there's going to be two states that we're going to test, right? For now. Again, these are like these are globals, unfortunately. But we have these two states now set up. So now we have the field that we can use in our collision system. So we need to get the actual state from the state machine. So what is it? So this is just the index. Let's look at our state machine processor real quick. So yeah, we have the state machine registry, which we're going to use. We're going to have to pull it from the registry. Yeah, we need something like this. It'd be nice to have a shortcut function, but for now, I know I keep saying for now. We need to do something like, not self.registry, but something like this. The plumbing is getting a little more spaghetti-like, unfortunately. We'll have to clean it up. But, yeah, I keep saying but quite a bit. State machine registry. So this should actually return, yeah, so she'll be able to get a state here. We can do something like this, hopefully. Capture a state. And then, just for now, and then action name equals state dot name. Hopefully that works. Okay. So we get the state, and then we need to find the action, giving the state name. Obviously that might not work, so we do if action data, and then we'll have to like translate the action data. Well, we'll have to look through all the hitboxes. Let's just comment this out for a little. Well, we'll have to do action data dot hitbox groups. I think it's hitbox group. Is that right? Where's our action here? Vulnerable hitbox groups. Okay, so let's do just to get going here. Let's group, and then we'll have to do for hitbox group dot items. Is that right? Hold on. Yeah, dot items. Whoops, I messed up here. No. That's not what I do. Hitbox group, that's actually a property of the hitbox. Sorry, I'm just thinking to myself a lot here. Action bot hitbox groups. It's actually hitbox group type, a struct, which has hitboxes. Okay, so we need to do collision system again. Dot hitboxes. We're just getting all the hitboxes for now, right? And then we'll need to add to our scratch hitboxes. For now, we'll just throw that value away. For now, we'll deal with it here in a second. Yeah, hitbox. Okay. Okay. Translate. Well, let's get all the hitboxes for the current active action. Okay. This current action. Just to remember what we're doing there. It'll coerce to it. Okay. Okay. So maybe there's some errors here. Wait, can while capture the index? Always. Is there a while? Oops. Just to check. What is this? Oh, there's no capture of the index. Oh, you can do this though. You can do this. Okay, I forgot about that. I want to do something like this. Is this post? Hold on. Wow. Okay. While. Loop is continued. So something like this. So I shouldn't have to do anything like that down here. Okay, let's just see what errors we have popped up. We wrote a lot of code here, so I don't know what errors are going to pop up. Okay. So that doesn't work. Wait, I did not initialize entity? Okay. Oops. Okay, var entity equals 0. That's going to work. Oh, wait. I had that there. What? My brain is just not catching this stuff. While can capture an optional no index. Oh, okay. That makes sense. I guess like if compet. Compet. Okay. I am kind of impressed how quick, when it does work, autocomplete or suggestions are pretty fast in Visual Studio with this. Did I write compet again? How do I even miss that? Yeah, I'm just trying to catch all these errors real quick. Current state. Error. Unused local constant. Gotcha. Wait, I didn't use this? Okay. Oh, self. That's why. Ooh, okay. I put self here. Okay, well, it runs. Just ignore this right here. I was just testing this. If you saw the Discord, I was just testing all that nice stuff. Well, just testing whether or not I could use this debug GUI framework called, I guess it's Ray GUI. Again, I'm not going to submit any of that stuff, so don't worry about it. Okay, we can compile now with what we wrote. We're still not there. What we need to do. So let's just, before we finish the stream, because I realize it's an hour and a half in, I need to cut it off here so it doesn't get too long. Let's just go to our documents here, planning. So we didn't create a character asset and load it when starting the game yet. Use loaded character data when executing action. So everything's like kind of partially done here, right? Because we haven't Alex been able to validate this. So let me update the outline and agenda. So P is for partial for me when I'm documenting what I've done. So again, this is partially done. Because we haven't validated all the way through. Okay. But let's just write down what we did do. We did create a action name hash map for looking up actions in the character data. So that was done. Wrote test validating use of the action name map. I don't have the right hash here. That's the right map. That was done. Everything else, we're in progress. So what do we need to do though? We still need to get the character asset loaded. I added a new task today. Well, wait, no. Hold on. Okay. Yeah. So we're pretty close. I need to write a JSON file that tests all this stuff. I need to load it when initializing the game. Yeah. I need to, what else I need to do? Well, we have the collision data setup phase. Oh, we need to copy. So we need to copy translated hitbox data into the Scratch hitbox memory for the collision system. That needs to be done. We discarded that stuff for now, but we need to copy it over. So we get that done. We can at least pipeline from the character data into the collision system. And we already have the part where we're iterating over all the collision boxes, and we're going to, so then what I need to actually get done is have the two characters on screen, move them around, have them collide. and generate the event. So we'll have to load 2 characters from data, not just one. And I'll probably have some debug stuff for showing the hitboxes. Yeah, I think that's pretty much where I want to go next time. If there's any other questions about this, just go ahead and ask now, and I'll finish the stream real soon. But in the meantime, I'm going to go ahead and post our Discord group if anybody who wants to join who's new here, and the GitHub link for the project. And I'll try to submit this stuff as soon as possible. So just going to go ahead and copy that into the chat. Discord link and our GitHub project. Yeah. That's been just a general comment though. Experience of like learning a language for something like Zig. It's difficult, but I think the language has a lot of positive things going for it, and just the source code being so readable has made this much more smooth. The consistent use of syntax throughout the language has made things also very, very easy to adopt. But yeah, that's it really. Really, if you have any questions, go ahead and ask. Otherwise, I appreciate again I appreciate everybody coming by, participating. You know, without you, things would go a little bit more slowly, maybe quite a bit more slowly, and more error prone. Thank you to all the Zig guys out here who know the language much better than me. Christoph and Trosep. Sorry, I'm having trouble reading some of these names. But yeah, I hope you guys come by again. You all come by again. And yeah. It's cool, Comic Man. If you can learn a little bit, I think that's what's important, even if it's just a little bit. My philosophy about learning things is just a little bit at a time. Make mistakes is fine, but you can learn to correct them later. Okay, well, I think that's it. I hope everybody has a good evening. If you're out here in Asia or in Europe, enjoy your morning, rest of your day. I'll have to get to my actual paid job here soon, so. Oh, absolutely, Tricep. Okay. Well, again, hope you see you all soon. Heading out now. And, yeah. Peace.